Have you ever had a client call you and ask, "Hey, who changed this order? What did it look like last week?" And you had absolutely no idea how to answer that? Today we're going to fix that permanently. I'm going to show you MariaDB's built-in system versioning, a feature that automatically keeps a full history of every change in your database, with 0 custom triggers, 0 extra audit tables, and 0 complex logic with the help of a free SkySQL MariaDB serverless instance. To kick things off, let's spin up a free serverless MariaDB instance using SkySQL. Just head over to the SkySQL website and sign up. You can use your Google account to get started in seconds. Once your instance has been provisioned, navigate to your SkySQL dashboard. Under the Services section, you should see your newly created instance listed there. Click the Connect button and a panel will appear showing your connection details, including the host address, port number, username, and password. Make sure you copy these down so we can use them to connect to the database. Use any Maria client application to connect to our new database. Now that we've successfully established our connection, let's go ahead and create a sample database. From there, we'll walk through exactly how system versioning works in MariaDB and what it looks like in practice. Now let's create a sample table called products. We'll enable system versioning on the entire table, meaning every column will be tracked automatically whenever a row is inserted, updated, or deleted. To do that, we simply append with system versioning to the end of our create table statement, no triggers, no extra audit tables, just one line and MariaDB takes care of the rest. As you can see on the screen, we've inserted a sample record into our products table and then ran 2 update statements against it. Now let's retrieve the full history of those changes. We'll use the for system_time all clause on our select statement. This tells MariaDB to return not just the current version of the row, but every version that has ever existed, along with the row_start and row_end timestamps that tell us exactly when each change happened. We can also be more precise with our history queries. Instead of retrieving all versions using for system_time all, we can use the AS of timestamp clause to filter by a specific point in time. So for example, if you want to know what your products table looked like on a particular date and time, you simply pass in that timestamp and MariaDB will return the exact snapshot of the data as it existed at that moment. Now let's look at how we can selectively exclude certain columns from system versioning. In a production system, you'll often have fields that update very frequently but aren't meaningful for audit purposes, things like a last_login timestamp, a view_count, or a last_updated column. Versioning these fields would create a new history row on every single update, causing unnecessary storage growth and write overhead. By marking those columns without system versioning, we're telling MariaDB to skip them entirely, so only the business-critical fields get tracked. This is one of the most important optimizations you can make before enabling system versioning in production. In this example, I've applied without system versioning to the last_login and login_count fields on our users table. Now when I run updates against the other columns, say the user's name or email, you can see MariaDB is capturing each of those changes and creating a new version row in history, exactly as expected. However, notice that when last_login and login_count are updated, no new history row is created at all. Those changes happen silently in place without touching the version history. This is precisely the kind of fine-grained control that makes system versioning practical for real production systems. You get full auditability where it matters, without the storage and performance cost where it doesn't. So here's our final verdict on using system versioning in production. While it is an incredibly powerful built-in feature, it does introduce additional overhead to your database. Every write operation now does more work under the hood, archiving old row versions, managing timestamps, and growing your storage over time. That's a trade-off you need to evaluate carefully for each table in your system. The golden rule is to use system versioning only where it is genuinely essential, tables that have a real audit, compliance, or point-in-time recovery requirement. For everything else, leave it off. When you do enable it, always back it up with proper partitioning and a clear retention policy, and exclude any columns that don't need to be tracked. Used thoughtfully, system versioning is one of the most valuable tools MariaDB offers. Used carelessly, it will quietly hurt your performance and storage over time.